down to solving one-step inequalities with multiplication and division. And we have again how we start this is by defining the word solve, which means to find all the values a variable can be that will make an equation or inequality true. And as a reminder from our last video that an equation has one answer, like x equals -2, the only answer is -2. But in an inequality, like x is greater than -2, there are an infinite number of answers because anything greater than -2 makes that statement true. We'll also review quickly that inverse operations are operations that undo each other. Addition undoes subtraction, multiplication undoes division. And we're going to remind ourselves to use the balance line because the balance line tells us that what we do on one side, we must do to the other. And the final thing we need to remember is we need to move our variable to the left side so that we can graph and we can read a statement from left to right, beginning with our variable. There is one tricky thing with multiplying and dividing to solve inequalities. And on your page, you see this set up. I have a statement, 5 is greater than 4. Is this a true statement? Is 5 greater than 4? Yeah, that's true. 5 is greater than 4. And I know that if I put a balance line into this inequality, if I do something on one side and do that to the other, then these statements come out the same. So, for example, if I multiply both sides by 2 and got 10 is greater than 8, is that still true? Is 10 greater than 8? Yeah, that is true. I multiplied both sides by 2 and came up with another true statement. But watch what happens when I multiply both sides by -1. When I multiply 5 by -1, I get -5. When I multiply 4 by -1, I get -4. And -5 is not greater than -4. It's actually less than -4. If I was looking at a number line, here's 0, -1, -2, -3. Here's -4. Here's -5. It's actually less than. So what we have to do is flip the symbol. Look at what it was here, and look at what it is now. I flipped the symbol to be facing the other direction. So on your paper, you have room to write in this rule. It's a really important rule. When you multiply or divide by a negative number, you reverse the direction of the inequality symbol. So the symbol was facing one direction, now I have to face it the other direction because of what we just saw on this page. When I multiplied by a negative, I ended up with a false statement. The way that we made it true was by switching the symbol to face the other way. Now this is a true statement. -5 is smaller than -4. So I've got two examples here for us to solve, and I'll put in my balance line on both of them. And that rule that we just wrote down doesn't come up on every problem. It's only when we multiply or divide by a negative number. So in this first problem, I see d divided by 9. The opposite of divide by 9 is multiply by 9. So multiply both sides by 9. This actually turns into a giant 1 on this side. If I did this, I would get 9d over 9. And just like we do in class, I would turn this into a giant coefficient of 1, but I'll just write d. And look at what I've written over here in blue. I multiplied by 9. Did I multiply by a negative number? No, I did not. So my symbol doesn't switch. It stays the same as it was. And I need to do 18 times 9. If you don't know 18 by 9 in your head, then you're showing that word and coming up with the answer G is greater than 162. To sketch my graph, I just make a short little number line. I put 162 in the middle, and I need one number smaller and one number larger, and then I can fill in my graph. This symbol means it will be an open dot because 162 is not included, but it's everything greater. So everything going that direction. And as you can see, my symbol shows me that I'm going that direction. On this second example, I see that I am multiplying by -5, and the inverse of multiply by -5 is divide by -5. Balance line reminds me to do that on both sides. This becomes a giant coefficient of 1, and 1x is just x. And now I need to look at what I've done over here. Did I multiply or divide by a negative number? Yeah, I divided by -5. So that's going to switch my inequality symbol from facing this direction to this direction. It got switched because of the dividing by -5. 35 divided by -5 is -7. So now I have something that I'm ready to graph. You put my number line down here, and I've got -7. You need to be careful when you're numbering the negative way. -6, -7, -8. I can see that I'm going to have a closed dot because this says that it could be equal to -7, so I need to have a closed dot. And it says x is greater than, so I'm going everything to the greater than, to the right. And again, my symbol shows me that the arrow goes that direction. Here are two more examples for you to try. So you're going to put in a balance line, and you're going to make sure to sketch these graphs. And one final question. You're going to put in a balance line, and I wrote be careful on this one, because this problem is actually going to have a double switch. What I mean by double switch is that you're going to have to switch because of this negative. And you're going to get an answer with a U and some symbol. Let me erase that. I don't want you to be confused. You're going to have a U and you're going to have some number over here. And then you're going to have to switch one more time to rewrite it so that my variable, which is U in this problem, so that the U is on the left, the number is over here, and I'm going to have to switch that symbol again. So this problem actually has a double switch. I want you to try it on your own. Just be careful that we're switching twice. One, because of the negative, and once more to rewrite this so that the variable is on the left.